Imagine writing a blank check to a robot, handing it the keys to your company's server room, and just, hoping for the best.
Yeah, which sounds terrifying.
Right. But honestly, for the last year, that is exactly what deploying generative AI in a large enterprise has felt like. So, welcome to this exclusive deep dive. Today, we're issuing a direct briefing on the Amazon Bedrock and AWS AI ecosystem, specifically looking at the week of April 12th to April 18th, 2026.
And this specific week is important because, well, if we look back at the history of cloud computing, there is always this distinct moment, a moment when a technology stops being this highly experimental, chaotic playground.
The Wild West, basically.
Exactly, the Wild West. It stops being that and it matures into a heavily governed, financially trackable enterprise operating system. And looking at the sheer volume and the nature of the updates AWS pushed this week, I'd argue that transition has officially occurred for generative AI.
And you, our listener, are likely tuning in because you're trying to keep up with the blinding pace of enterprise AI. You need to separate the actual architectural shifts from the marketing noise, and you want to understand how this tech actually works, right? Without getting completely bogged down by a dictionary's worth of engineering jargon.
Which is completely fair.
Yeah.
So that is the mission for this deep dive. We're going to examine the models, the routing features, the safety guardrails introduced this week. But more importantly, we want to explain how they all interlock, how they solve the very real, very tangible operational bottlenecks holding up enterprise adoption.
Let's start with the foundation then. Before we can touch on how developers are, actually building with Bedrock, we have to look under the hood at the engines powering everything.
The models themselves.
Right. And looking at the AWS news blog from April 16th, the biggest headline is the global launch of Claude Opus 4.7 from Anthropic, which is now directly integrated into Amazon Bedrock.
Right. And this represents Anthropic's most capable Opus model to date. What stands out immediately, at least to me, is the sheer scale of the inputs it's engineered to handle. We're looking at a 1 million token context window.
Wow.
Yeah, and that is natively combined with high-resolution vision support that scales up to 2,576 pixels. It also features what Anthropic describes as adaptive thinking.
Adaptive thinking, meaning it can adjust on the fly.
Exactly. It allows the model to dynamically allocate compute resources based on how complex the prompt is.
And the performance metrics on this are notable. It's scoring 64.3% on SWE-bench Pro. And for anyone not living in the developer testing weeds, SWE-bench Pro doesn't just ask an AI to solve isolated toy coding puzzles.
It's much harder than that.
Yeah, it evaluates the model's ability to resolve real complex issues from real GitHub repositories. And on top of that, AWS is offering immediate capacity of up to 10,000 requests per minute per account. But okay, looking at the physics of this, I really have to question the infrastructure.
What's the primary concern there?
Well, a 1 million token context window combined with analyzing ultra-high-resolution images. That's roughly equivalent to asking someone to read the entire Library of Congress through a microscope.
That's a good way to put it.
And expecting them to do it thousands of times a minute. So how does the AWS infrastructure ingest that massive compute load without either, timing out the customer's application or creating a massive latency bottleneck?
The answer lies in the architecture running beneath the model. Bedrock has deployed a next-generation inference engine, internally associated with Project Mantle. So to handle that massive load, the engine relies on something called a leaky bucket scheduler.
Okay, in computer science terms, how does a leaky bucket scheduler actually function?
Imagine a physical bucket with a small hole in the bottom. You can pour water, or in this context, a massive, unpredictable burst of API requests into the top of the bucket at wildly varying rates. So instead of the system overflowing and outright rejecting the customer's requests, the bucket catches the burst. The requests then essentially leak out of the bottom at a steady, manageable, constant rate into the inference processors.
Oh, so it acts as a buffer.
Exactly. It handles traffic spikes gracefully. And crucially, this engine operates on a strict principle of zero operator access.
Wait, so if there is zero operator access, AWS engineers are essentially blinding themselves to the customer's data.
Yes.
I mean, that must be the only way a highly regulated bank or a healthcare provider would ever let a model process their proprietary code or patient records.
That is the exact mechanism. Neither AWS nor Anthropic can intercept, view, or use the prompts and responses for training. For compliance boards, that cryptographic separation is the ultimate green light for enterprise adoption.
That structural security is a massive upgrade. But there's another Anthropic model announcement from the AWS News blog, this one dated April 13th, that takes a completely different approach to release governance. Let's talk about the Claude Mythos preview.
Yes, so this was launched under an initiative called Project Glasswing, and it represents a real paradigm shift in how frontier models are distributed. Mythos is a new class of AI strictly focused on discovering and addressing zero-day cybersecurity vulnerabilities.
Okay.
And it delivers state-of-the-art vulnerability detection with very minimal manual guidance from the user.
I really have to pause on the implications of that. If it finds zero-day vulnerabilities with almost no human guidance, AWS is essentially hosting a master skeleton key for global software on their servers.
Right, I see where you're going with this.
I mean, the inherent risk of an AI that is elite at finding exploits seems astronomically high.
And that risk profile is precisely why AWS has not made this model generally available. Frontier cyber capabilities require a totally different release paradigm than a standard language model.
So it's locked down.
It's extremely locked down. It's operating under an invite-only allow list. AWS and Anthropic are prioritizing internet-critical infrastructure companies and open-source maintainers. The whole strategy is to give the structural defenders the skeleton key so they can patch the locks before the broader public or, malicious actors even know the vulnerability exists.
Okay, so we have Opus 4.7 for massive reasoning tasks and Mythos secured in a vault for elite cybersecurity. But there is a third model development from this week, published on the AWS machine learning blog on April 17th, focusing on pure efficiency. AWS released a workflow for using Bedrock's distillation feature to optimize their proprietary Nova models.
The distillation workflow, yeah.
Right. Specifically, they transferred complex multimodal routing intelligence from a massive teacher model, which is Nova Premier, into a highly compressed student model, Nova Micro.
To understand why this matters, we have to look at the mechanics of semantic video search. When a user searches a massive corporate video database, the AI system first has to route the intent.
Like figuring out what the user actually wants.
Exactly. It has to ask, is the user looking for a visual cue, an audio cue, or a specific phrase in the transcript? Historically, relying on a large language model to make that initial routing decision was causing something like 75% of the total search latency.
Because this system was forcing a massive computationally expensive model to perform a relatively simple traffic cop job before it even started searching the video.
Correct. Distillation solves this. In model distillation, the massive Nova Premier model acts as the teacher. But it doesn't just give the small Nova Micro model the right answers. It passes down its probability distributions. Essentially, its intuition on how to route intents.
So the student model actually learns the underlying pattern.
Yes. And the result of this specific workflow is striking. Inference costs were cut by over 95%, and total latency dropped by 50%.
Wow.
And that's all while maintaining the exact same routing accuracy as the massive model.
Tracking costs down by 95% is a perfect pivot here, because having elite models or distilled routing layers is completely useless if the enterprise goes bankrupt trying to scale them in production.
Absolutely. And this is where the conversation moves from the research lab to the chief financial officer's desk. The operational and financial tooling updates this week are arguably as significant as the models themselves.
Yeah, so on April 17th, the machine learning blog detailed granular cost attribution for Amazon Bedrock. The platform now automatically tracks inference costs at the IAM principal level.
Which is huge.
Huge. And for those outside the cloud architecture space, an IAM principal is essentially the digital ID card of the specific user, the specific application role, or the federated identity making the API call. Bedrock now pushes this data directly into AWS Cost and Usage Reports, known as CUR 2.0, and AWS Cost Explorer.
Prior to this update, tracking generative AI spend in a massive organization was an accounting nightmare.
I bet.
Organizations were receiving aggregate bills for millions of tokens and had no native way to determine which department was responsible.
It's the classic restaurant bill problem. A company hosts a 50-person dinner party, and at the end of the night, AWS just hands the table one single, massive, confusing check. Everyone is looking around trying to figure out who ordered the expensive wine.
Exactly.
But with IAM level tracking, it is like the waiter effortlessly walking around and handing every single person their exact itemized receipt. It stops AI from becoming this giant, untrackable slush fund.
That's the operational reality now. Finance teams can tag and track AI spend down to specific engineering teams or even individual developers. And they can do it without having to engineer complex custom proxy servers just to monitor who's making API calls.
So the CFO gets their itemized receipt. That's great. But what about the chief technology officer? They have a completely different nightmare, which is duplicated effort. On April 13th, AWS announced the Agent Registry preview inside Amazon Bedrock Agent Core. This is a private, centralized catalog for discovering, sharing, and managing AI agents, tools, and Model Context Protocol, or MCP, servers.
Let's unpack the problem this solves. In large enterprises today, you might have a marketing team building an agent to query a database, while the HR team is spending 2 months building the exact same database querying agent.
And neither knows the other exists.
Exactly. This is known as agent sprawl. The Agent Registry attacks this by providing semantic search across the organization's entire catalog of AI assets.
And it includes CloudTrail audit logs, which means the security team can actually verify what these agents are doing. You also mentioned MCP servers. The Model Context Protocol is essentially the universal plug that standardizes how AI models connect to external data sources, right?
Right.
So the registry lets developers share not just the bots, but the standard data connections as well.
It creates a standardized governed repository. You discover what has already been built, verify that it meets compliance standards, and reuse it rather than starting from scratch every single time.
If you're an enterprise developer listening to this right now, especially a Java developer, you might have felt sidelined by the generative AI boom, which has heavily favored Python. But an announcement on April 14th changes that reality.
The Spring AI update.
Yeah, AWS announced general availability for the Spring AI SDK for Amazon Bedrock Agent Core. This gives Java developers native tools to build Bedrock agents with managed runtime, memory, and browser automation. But I have to ask the obvious question here. In the era of cutting-edge AI, isn't Java considered, well, legacy infrastructure? Why invest so heavily in it?
That is a very common perspective in the startup ecosystem, sure. But it ignores the reality of global infrastructure.
How so?
If a generative AI tool is going to move from a pilot program into revenue-generating production, it must integrate into the enterprise stacks that already exist. The world's largest banks, healthcare networks, global logistics companies, they run their core transactional systems on the Java and Spring ecosystem.
Oh, so you can't just rip all that out.
Exactly. By making this SDK generally available, AWS is allowing these massive enterprises to natively weave advanced agentic AI into the fabric of systems they've trusted for decades.
You have to meet the enterprise where it lives. That makes sense. Another crucial developer tool focused on model customization dropped on April 17th. AWS released a guide on using the Nova Forge SDK for data mixing, utilizing AWS SageMaker. They demonstrated a methodology for fine-tuning a model by mixing a ratio of 75% customer proprietary data with 25% Nova baseline data.
And the mechanism of data mixing here addresses one of the most frustrating phenomenons in machine learning. It's known as catastrophic forgetting.
Catastrophic forgetting sounds dramatic.
It is, honestly. When an engineering team fine-tunes a foundation model too heavily on their own highly specific corporate data, the model often becomes excellent at that specific task, but it suddenly forgets how to perform basic general reasoning.
Like it over-indexes on the new information.
Exactly. But by utilizing this specific 75 to 25 ratio, AWS demonstrated a 12-point improvement in the F1 score on a complex classification task.
And to clarify for everyone, the F1 score is a metric that balances precision and recall, meaning the model accurately identified the right data without just blindly guessing yes to every problem.
Right. But what is critical here is that while improving that specific task, the model's MMLU score, which tests massive multitask language understanding across dozens of academic subjects, stayed practically flat. It moved only from 0.75 to 0.74.
So it didn't forget the basics.
It definitively proves that with the right data mixing architecture, you can teach a foundation model highly specific proprietary rules without destroying its foundational logic and general intelligence.
That's fascinating. But implementing all of this, Java-based agents, massive multimodal routing, highly specific fine-tuning, it requires immense physical compute power. Let's look at the actual silicon processing these requests. On April 15th, AWS published a benchmark regarding their custom AWS Trainium chips.
Right. The benchmark focused on an inference optimization technique called speculative decoding. AWS demonstrated that by using speculative decoding on Trainium chips, specifically running VLLM and Qwen3 models, they can drastically improve intertoken latency.
Let's break down the mechanism of speculative decoding. How does it actually speed up the hardware?
In standard generative AI, the massive foundation model generates text one token or word at a time. It's highly accurate but computationally slow. Speculative decoding introduces a second, much smaller, highly efficient draft model.
A draft model.
Yeah, the small draft model races ahead, guessing the next 5 or 10 words. Simultaneously, the massive main model reviews those guesses. If the draft model guessed correctly, the main model accepts them all instantly. If the guess is wrong, the main model rejects it and computes the correct word itself.
So it's like a junior assistant rapidly drafting a document while the senior executive reads over their shoulder, instantly approving the good parts and only stepping in to correct the mistakes.
That is a great analogy.
And AWS reported this accelerates token generation by up to 3x for decode-heavy, large language model workloads.
And that 3x speedup fundamentally shifts the economics of deployment. For a long time, the industry was obsessed with time to first token. How fast the AI simply starts responding.
Right.
But in multi-step agentic reasoning, where an AI agent might independently think through a problem, write a script, execute it, read the error log, and then rewrite the code, the generation speed is the only metric that dictates whether the process is economically viable. Speeding generation up by 3x fundamentally lowers the serving cost for these complex loops.
Moving fast on custom silicon is impressive, but if you're operating in a regulated industry like finance or healthcare, speed without breaks is a massive liability.
A huge liability.
So the update on April 16th addresses this directly, introducing automated reasoning checks in Amazon Bedrock Guardrails.
This is perhaps the most significant governance update of the week. AWS states that these automated reasoning checks use formal mathematical verification to validate AI outputs against explicitly defined rules, rather than relying on probabilistic AI as a judge models.
Okay, I need to challenge a premise there. Generative language is inherently fluid and unstructured. How do you apply rigid, deterministic mathematical proofs to a paragraph of generated text?
To understand the mechanism, we really have to look at the difference between probability and determinism. Historically, if you wanted to check if an AI gave a compliant answer, you used another AI model to read the output and guess, probabilistically, if it looks safe.
But a 95% confident guess is not legally binding.
Exactly. The automated reasoning engine changes this entirely. Let's look at the specific use case AWS provided with Amazon Logistics.
Okay, the article mentioned Amazon Logistics uses this to evaluate electric vehicle charging point, or EVCP, deployment parameters.
Correct. Amazon Logistics has to ensure every proposed charging station meets incredibly complex, rigid regional regulations regarding power output and spacing. Previously, a human engineer spent up to 8 hours manually cross-referencing a proposal against the regulatory code. Under the new workflow, Claude in Amazon Bedrock reads the unstructured fluid proposal and extracts the hard technical specifications into structured data.
So the AI extracts the variables, but where does the math come in?
Those extracted specifications are then fed directly into the automated reasoning engine. The engine does not guess. It mathematically verifies those specific data points against the logical constraints of the regional regulations using formal logic gates.
Oh, wow.
It's binary. It either proves mathematical compliance or it blocks the output completely.
Which cuts the engineering review time from 8 hours down to mere minutes.
And more importantly, it provides compliance teams with audit-ready, provable evidence of safety. If an enterprise is dealing with stringent frameworks like the EU AI Act, they cannot tell a regulator that an AI simply guessed it, followed the rules. They require the deterministic mathematical proof that Bedrock Guardrails is now capable of providing.
We've mapped out the entire architecture now. We've examined the raw power of Opus 4.7, the cost tracking down to the IAM principle, the Java integration for legacy systems, the 3x speedup on Trinium Silicon, and the mathematical safety rails. The final question is, who is actually deploying this ecosystem in production today?
The enterprise adoption case studies published this week show this is no longer theoretical. On April 15th, AWS highlighted Rede Mater de Saúde, a large Brazilian hospital network.
Great.
They deployed a suite of 12 AI agents running on Amazon Bedrock Agent Core to manage their complex revenue cycle.
Yeah, these agents are handling administrative burdens like contract management, ERP parameterization, and insurer authorizations. And the metrics published are staggering. In just 4 months, the hospital network generated a 517% return on investment. They reduced the time required for insurer authorization by 66%.
That's massive.
And because the paperwork was processed faster, they cut actual surgery start delays by 33%.
That is the ultimate realization of this technology. It's not just about writing emails faster. A heavily governed administrative backend moving at the speed of compute creates a real physical impact on patient care operations.
AWS is also utilizing these tools internally. On April 17th, they detailed how their own marketing team used a partner tool called Granular, which is built on Amazon Bedrock. They created an agentic workflow that orchestrates web page assembly, layout, and real-time compliance validation entirely through natural language commands.
The efficiency gains there basically redefine team productivity. They compress the time required for web page assembly from up to 4 hours down to approximately 10 minutes.
Sure. A greater than 95% reduction in manual effort, allowing the marketing team to focus on actual strategy rather than, formatting layouts.
Exactly.
Finally, on April 16th, there was a major announcement from the financial sector. Q2 Holdings launched a governed AI development environment natively on Bedrock using Claude Code. They named the platform Q2 Code, and it is designed to serve their base of over 1,000 digital banking clients.
This is the ultimate stress test of the zero operator access and security posture we discussed earlier. Q2's platform protected against $1.4 billion in check and ACH fraud last year alone. A Wall Street-level compliance environment requires absolute data sovereignty.
Because Bedrock guarantees that neither Anthropic nor AWS can view the proprietary code, Q2 is able to deploy these tools safely. It allows them to compress their development cycles from weeks down to days, pushing cutting-edge features to massive digital banking clients without tripping compliance alarms. Synthesizing everything we've analyzed today, the narrative is pretty clear. Through a combination of elite models, precise financial tracking, legacy code integration, and deterministic mathematical safety, AWS has spent this week proving that generative AI is finally ready for the corporate boardroom.
It is the definitive transition from the experimental playground to the enterprise operating system, which leaves you with a final thought to ponder as we conclude this deep dive. Now that Amazon Bedrock can track AI costs down to the individual user and mathematically prove the safety of its outputs, the biggest bottleneck to AI adoption is no longer the cloud infrastructure. The bottleneck is human organizational structure.
That's a great point.
If a Bedrock agent can assemble a web page in 10 minutes instead of 4 hours, or cut hospital authorization times by 66%, are our human teams actually structured to keep up with an AI that moves that fast? Are our legacy management workflows ready to operate at the speed of compute?
It is the operational question every IT and business leader must confront as these systems come online. Thank you for joining us as we extracted the signal from the noise in this week's AWS AI ecosystem. We will be right back here next time to take another deep dive into the architecture of innovation. Until then, keep exploring.